Science 10, Quarter 1, Earth Science. Lesson 1, Week 1, Distribution of active volcanoes and major mountain belts. In this video, we will discuss earthquake and how to find its epicenter. Let's define first the earthquake. Earthquake, a sudden and violent shaking of the ground produced by the rapid release of energy. There are two ways on how we can measure the strength of an earthquake: magnitude, and intensity. Magnitude is a quantitative measure of the size of the earthquake at its source. It is proportional to the energy released by an earthquake at the focus, represented by Arabic numbers, and calculated from earthquakes recorded by an instrument called seismograph. How about intensity? The intensity is a number, written as a Roman numeral, describing the severity of an earthquake in terms of its effects on the Earth's surface and on humans and their structures. In the Philippines, the intensity of an earthquake is determined using the PHIVOLCS earthquake intensity scale. We already know what an earthquake is and how to identify its strength, so let's proceed to the causes of an earthquake. There are three major causes of an earthquake. Number 1 is volcanic eruption. Earthquakes occurs in areas with frequent volcanic activity. When boiling magma wants to reach the Earth's surface, it can cause a certain movement in the Earth's crust. Second, is geological fault and plate movement. The movement of rocks along these planes brings about tectonic earthquakes. These faults occur due to the impact of geological forces. The displacement of plates creates the fracturing of rocks, which releases a lot of energy. Third is man-made. The activities of man with nature can also become a cause of an earthquake. The best example of this is nuclear bombing and mining. Let's proceed to the different terminologies related to earthquakes that we need to remember. Seismologists, seismograph versus seismogram, seismic waves, and epicenter versus hypocenter. Let's start with seismologist. Seismologists are earth scientists, specialized in geophysics, who study the genesis and the propagation of seismic waves in geological materials. The fundamental work of a seismologist is to locate the source, the nature, and the size, magnitude, of these seismic events. Now, let's proceed to the difference between seismograph and seismogram. Seismograph versus seismogram. Seismograph is an instrument that measures and records details of earthquakes, such as force and duration, while seismogram is a record produced by seismograph. Next is seismic wave. Seismic wave are waves of energy caused by the sudden breaking of rock within the earth or an explosion. It can be classified as surface waves or body waves. Surface waves can move along the surface of the Earth. It has two types, Rayleigh wave and Love wave. Rayleigh causes the ground to shake in elliptical pattern, while Love waves move the surface from side to side motion perpendicular to the direction of propagation. The other type of seismic wave is the body wave. This type of wave can travel in the interior layers of the Earth. It has two types, P waves and S waves. The first kind of body wave is the P wave or primary wave. This is the fastest kind of seismic wave, and, consequently, the first to arrive at a seismic station. The P wave can move through solid rock and fluids, like water or the liquid layers of the Earth. It pushes and pulls. The rocket moves through just like sound waves push and pull the air. P waves are also known as compressional waves, because of the pushing and pulling they do. The next type of body wave is the S wave. The second kind of body wave is S wave, or the secondary wave. This wave is slower than P waves. It has an up and down motion pattern and travels in solids only. S waves can generate greater size, resulting in more damage. We're done with the seismic waves and its different types. Let's proceed to the anatomy of an earthquake. We will differentiate the epicenter from the hypocenter or focus. Let's discuss the difference between epicenter and hypocenter or focus. In the diagram presented, the plate movement, fault, and seismic wave. It also shows the epicenter and the hypocenter. As you can see, the hypocenter is the exact location where ruptures or earthquakes happen, while the epicenter is the location right above the focus. That's all about earthquake, and we will discuss the step-by-step process on how to find the epicenter on the next video.